This is a pre-lecture video on growth accounting for the course Global Business Economics. I'm David Frankel, a professor at Melbourne Business School. Let's begin. We start with an important question. How is the level of output Y in a country determined? Economists have identified three key inputs to production at the national level. The first is physical capital K, buildings and machinery. The second is labor hours L, the total number of hours worked by all of the workers in the country over a given period of time. The third, denoted H, is human capital, the labor market skills of the typical worker in the country. Next, economists combine these inputs in what is called an aggregate production function. We will work with the Cobb-Douglas production function that is depicted on the slide. In this function, output Y is written as the product of three terms. It is convenient to begin with the second term. This term is physical capital K raised to a power alpha. The parameter alpha is interpreted as the share of national income that goes to capital and is usually estimated at about 0.4. That is, about 40% of national income is received by the owners of capital in the form of interest, dividends, rents, and so on, while the remaining 60% is received by workers in the form of wages. The third term is the product of H and L raised to the power of 1 minus alpha. The product of H and L is known as effective labor. Labor hours L adjusted for the effectiveness of labor as measured by the human capital H of the typical worker. We turn finally to the first term on the right-hand side, denoted by the letter A. This term is called total factor productivity, or TFP. It captures everything that affects output Y other than physical capital K and effective labor HL. TFP-A captures such factors as a country's technological development, the strength of its democratic institutions, the protections of its legal system, and so on. In practice, data on human capital H is sometimes missing. In this case, we can combine TFP-A with the term involving human capital H to obtain a new variable, M. M is known as multifactor productivity, or MFP. MFP captures everything that affects output Y other than physical capital K and labor hours L. In particular, everything that affects TFP-A also affects MFP-M. But, as the notation suggests, MFP-M also includes the effects of human capital H on output Y. We now turn to some basic mathematics of growth rates. Let X denote any variable that changes over time: output, physical capital, labor hours, and so on. Let X sub t be the value of X in year t. For example, K sub 2020 is the amount of physical capital in the year 2020. We can measure the growth rate of X in two possible ways. The first is the arithmetic growth rate. This is just the change in X from one year to the next divided by its initial value. The second is the logarithmic or log growth rate. This is the natural logarithm of the gross percentage increase in X from one year to the next. For instance, suppose that human capital H grew from 2 in 2009 to 2.1 in 2010. The arithmetic growth rate is just the net percentage increase, which is 5%. The log growth rate is the natural logarithm of the gross percentage increase, which turns out to be 4.88%. As you can see, the two rates are nearly the same. Indeed, when the rates are small, the log growth rate is a good approximation to the more common arithmetic growth rate. In this video, we will use the log growth rate, which has some useful properties that the arithmetic rate lacks. In growth accounting, we will usually work with the average log growth rate over some multi-year period. This has a simple formula. To compute the log growth rate of a variable x from year t to a later year t prime, we first take the log of the gross percentage increase in x from year t to year t prime. We then divide this logarithm by the number of years in the period, by t prime minus t. For instance, suppose human capital H was 2 in 2005 and 2.3 in 2015. To compute its mean growth rate over this period, we take the log of 2.3 divided by 2 and divide the result by the number of years that have elapsed from the first year to the last, which in this case is 10. We obtain 0.014. In other words, the annual growth rate of human capital from 2005 to 2015 was 1.4%. As noted before, we use log growth rates because of their useful properties. These are as follows. Let x and z be any two variables, such as output y, capital K, and so on. Furthermore, let c be any fixed number, such as 0.3, 0.5, and so on. Then we have the following three rules. First, the growth rate of x times z is just the growth rate of x plus the growth rate of z. Second, the growth rate of x divided by z is the difference between the growth rate of x and the growth rate of z. Finally, the growth rate of x raised to the power c is just c times the growth rate of x. We first use these tools to study the sources of real output growth. Rules 1 and 3 from the prior slide are reproduced here for convenience. By Rule 1, the growth rate of a product is the sum of the growth rates. Thus, the growth rate of y is the sum of the growth rates of m, k to the alpha, and l to the 1 minus alpha. Next, by Rule 3, the growth rate of k to the alpha is alpha times the growth rate of k. Likewise, the growth rate of l to the 1 minus alpha is just 1 minus alpha times the growth rate of l. We have shown that the growth rate gy of output can be written as the sum of three terms. The first is the MFP growth rate, gm. The second is the contribution of physical capital growth, which is just the growth rate gk of physical capital times the capital share of income, alpha. The third term is the contribution of labor hours growth. This is just the growth rate GL of labor hours times the labor share of income, 1 minus alpha. We now decompose the growth rate of labor productivity, Y over L, output per labor hour. We again reproduce rules 1 and 3 for convenience. We first replace output Y in the numerator with its expression in the Cobb-Douglas production function. Next, we combine the terms that involve L in the numerator and denominator to obtain L to the negative alpha. We now combine the K and L terms, writing the result as the ratio of K over L to the power alpha. We next take growth rates of both sides and then apply rule number 1 to convert the second growth rate to the sum of MFP growth GM and the growth rate of K over L to the power alpha. Finally, we apply rule 3 to transform the final growth rate to the product of the capital share of income alpha and the growth rate of K over L. Summarizing, labor productivity growth is the sum of two terms. The first is MFP growth, GM. The second is the contribution of capital deepening, GK over L, of growth in the capital labor ratio. The prior two decompositions are both written in terms of multifactor productivity M. However, sometimes we also have data on human capital H. If so, we can replace GM in the prior decompositions with terms that involve the growth rates of human capital H and of TFP-A. This allows more detailed versions of the prior two decompositions. First, let us recall the definition of multifactor productivity M. It equals the product of total factor productivity A and human capital H raised to the power of 1 minus alpha. Next, we reproduce rules 1 and 3 for convenience. Applying rule 1, the growth rate GM of MFPM can be written as the sum of the growth rate GA of TFPA and the growth rate of human capital H raised to the power 1 minus alpha. Next, we apply rule 3 to write that last growth rate as the product of 1 minus alpha and the growth rate GH of human capital. We have shown that multifactor productivity growth GM equals the sum of total factor productivity growth GA and the contribution 1 minus alpha GH of human capital growth. Finally, we can use our tools to decompose the growth rate of per capita GDP, Y over N, where N is the total population of the country. We first write Y over N as the product of two terms, labor productivity Y over L and hours worked per capita L over N. The latter ratio is called labor utilization. Applying Rule 1, it follows that the growth rate GY over N of per capita GDP is equal to the sum of GY over L and GL over N. The upshot is that growth of real GDP per capita equals the sum of labor productivity growth and labor utilization growth. We now collect the 4 takeaways from our study of growth accounting. First, output growth is the sum of MFP growth, the contribution of physical capital growth, and the contribution of labor hours growth. Second, labor productivity growth is the sum of MFP growth and the contribution of capital deepening. Third, MFP growth is the sum of TFP growth and the contribution of human capital growth. And fourth, per capita GDP growth is the sum of labor productivity growth and labor utilization growth. This concludes the GBE pre-lecture video on growth accounting. Thank you for watching.